You are going to be asked to write linear equations either from a graph or from given information. So I like to categorize these into cases, case 1, case 2, and case 3. Case 1 is the easiest case you'll ever get. That's when they give you a slope and a y-intercept and they say write the equation of a line that has this stuff. So the best way to handle that is to apply slope-intercept form, which is y equals mx plus b. And all you have to do literally is just plug your information in for m and for b. So you could either have, for this particular problem, 6x plus negative 5, or 6x minus 5 equals y as your equation. Case 2, that's a little bit trickier. So they're kind of nice. They gave you the slope, but they did not tell you the y-intercept. So they're keeping that a secret, but they do have to give you something, and in this case, they're giving you a point. So there's two methods at which you can handle this. I'm going to show you the one that I'm guessing you might have learned in Algebra 1. So we'll call this method 1. Typically, teachers will tell their students to set up slope-intercept form. And then you're going to plug your y value in for y, your slope in for m, and your x value in for x, of course. And then you're going to be asked to solve for b. So if we go through the steps, I have to do negative 3/4 times 3, get negative 9/4. And then I'm going to have to add 9/4 to the other side. My goal is for you guys to be able to do this without a calculator. So when you're adding fractions with whole numbers, I want you to consider what would the whole number look like as a fraction. In this case, it would need to be over 4. So when you realize that 5 is the same as 24. So if I add those together, I get 29/4. That's my b value. So once you found your b value, then you're supposed to tie it all together in a pretty package. So your answer would be y equals negative 3/4x plus 29/4. Nothing wrong with that method. It's been taught for years. Totally understand it. If that's your strong suit, that's great. But I'm going to show you an alternative method. I think it's a little bit easier, actually. If you're given a point and you're given a slope, why not use point-slope form? Literally has the words point and slope in it. So what I teach my kiddos is to set up the point-slope formula and to underline the y1, the m, and the x1. That's where we're going to plug our information into. You can plug your information into the y2, m, and x2. That would be fine, but you're going to have a little extra bit of work to do at the end. So, and that typically causes a mistake to happen. So it's easier actually if you just use these three values. So I'm going to put 5 in my y1 spot. I'm going to put negative 3/4 in m, and 3 in my x. Now technically, the directions say, write the equation of a line that has this info. Well, that's what you did. This is an equation. It's a line. It satisfies the requirements. There you go. It didn't specify what form your equation had to be written in. So I'm just going to point that out to you, that if this was an actual test question, you could circle this and you'd be done. Far less work than if you use method 1. But just for the sake of practice, let's pretend that they said, present your answer in slope-intercept form. So we're not quite there yet. My next step would be to distribute negative 3/4 times x, negative 3/4 times 3. And then all I would need to do is add my 5 over. I'm trying to get y by itself. That's what it means to be slope-intercept form. And you're just going to get that same 29/4 this time, but steps are a little bit different. So this one has a lot of substituting, solving, and then resetting up. This is kind of, you plug in once, and then you just literally do the math. That's with it. So there's good and bad from both, but honestly, I've been teaching this method more than this method, and I see far less errors when kids use the point-slope form. So when we do case 3, that's going to be the most challenging. So you get 2 points, but they don't tell you the slope or the y-intercept, so you have to do it all by yourself. It's a little tedious, but totally doable. So just a reminder, you're going to start with your slope formula. You would have had to use this in Algebra 1, y2 minus y1 over x2 minus x1. And it doesn't matter if you want to call your order pairs x1, y1, x2, y2. You could do x2, y2, x1, y1. Either way is fine. You're going to put those in, and then you're going to solve and find your slope. So my slope in this case is 1/2. So your choice, either from this point on, you're going to treat it like a case 2. So you're either going to use method 1 or you're going to use method 2 and get your equation written. I'm going to use method 2 because that's the method I prefer. So I'm going to set up my point slope form. It's completely up to you. You can use 4 and 2 as your x and y, or you can use negative 2 and negative 1. It's not going to make a difference. Get the same answer regardless. Technically, I could circle that and be done. It didn't specify what form it had to be written in. So if this was a test question, you could circle it and you'd be done. Let's pretend that the directions said, present your answer in slope-intercept form. Right, so I have to do a little more work. We're going to distribute the 1/2 real quick, and then we're going to add 2 to both sides. No matter which way you do the problem, it's going to look like 1/2x. So in my next video, we'll cover some special examples, and then we'll go ahead and look at some graphs of lines.